In the next part of this section, we're going to actually do something a little different. We're going to actually try to work our way backwards. So before we were given information about the distribution and was able to find area or the proportion or probability of one side. Whereas now, what we're going to look for is we're not going to know much about the distribution, and we're going to actually want to find the value that corresponds to an area. So notice they could give us an area to the right of the value, or they could give us area to the left of the value, right? In any case, we would use this to play with the z-score formula to find x. So that's where this formula comes from in the steps above. Is it says, okay, well, if z was x minus mu over sigma, then multiply each side by sigma to get sigma times z equals to x minus mu, and then add the mean over, and so you get mu plus sigma times z equals x. But the only problem is that we need to find the z, right? If we had the z and the mean and the standard deviation, we could find this x value. So just by using the simple arithmetic formula. So the z-score, remember how we went before? They gave us the x, then we find the z, and then we use the calculator to find the area, right? But now what we're going to do is be given the area, then get the z, then plug and chug into here to get the x. So if we're only given if we're given the mean and standard deviation, then we could go ahead and just use those. We know a little about the distribution, and we can use the calculator to get x pretty quickly. However, if they just tell us, you know what? We just assume that z is equal to 0, which is the mean, and the standard deviation is 1, then we have to go ahead and use the z and formula. So let's take a couple of examples. So how it's different again is that we're going to work our way backwards. Instead of giving us x and then we find area, we're going to have area and then find x. We're just working our way back. So how do we do this in the calculator? Well, we are given the steps for the calculator, and instead of using that norm CDF, we're trying to do the inverse, right? So if we go to the calculator, they'll ask for the area, the mean, and standard deviation, and notice it doesn't matter. If you have this calculator, it will not matter what area you have. You just select the area and then paste. If we're given information about the distribution, we'll enter those in here, and then we can just get directly the x value. We don't have to worry about using a formula. Okay, so let's go to the example and see what this will look like. The combined verbal and quantitative reasoning score on the GRE is normally distributed with a mean of 1049 and standard deviation of 189. What is the score of a student whose percentile rank is the 85th percentile? So there's a few things. The first things I would tell you is that we know that the data is normally distributed. We know the mean is 1049 and standard deviation is 189. And we're looking for that barrier, the 85th percentile. So let's go ahead and put the mean as 1049. And they give us the little tick marks to label the x-axis. So let's go ahead and do that. I'm going to add and subtract 189 3 times to the right and 3 times to the left. So I did this ahead of time to save time. So 1238, 1427, and 1616. And then 480, oh, sorry, I'll go in order. So 860, 671, 482. And so the 85th percentile, just looking from left to right, remember 85th percentile, here's 100, and here's 0. 85 would be over here, right, where there's the top 15% and lower 85%. So we're looking for something that is around, I would say, here. Let me do it in a different color. Okay, where once again that the area to the left is 85%, right? Or you could say area is equal to 0.85. Okay. And that just means that this tail is 15%, or in other words, 0.15, right? You could use either one, but I'll just use 85 since we're doing the 85th percentile. So here, what we want is we want to see the GRE score that corresponds to the 85th percentile. So what we're looking for is the probability or area such that this x value is less than c, which is equal to 85%, right? And we want to say what is c. Okay, well, we know some pieces of information. We know that the mean is 1049 and the standard deviation is 189. So let's go ahead and use our calculator. So really, this C will be equal to invnorm, area to the left in our case. The mean is 1049, standard deviation 189, and our area is, we will select the left side. So let's go ahead and go to our calculator. We'll select invnorm, right? Second, let me just quit. The second vars, invnorm is number 3. And we'll put the area as 0.85. The mean is 1049. And the standard deviation is 189. And my tail is on the left side. Hit paste. And so notice that this calculator in particularly puts the left there, and because you can choose where the area lies. So automatically it gives us the value only because we knew the distribution, right? So 1244 point, I would do one decimal pass, maybe 1244.8. So then maybe we would say like 85% of the GRE scores are less than 1,200, I would round up to 45, right? 1245, and 15% are more than or greater than our scores. Greater than 1245. So even though we can find the C fast, what does this mean to our problem, right? And so this is kind of like our thought process. Now I used it as a proportion interpretation. I could say there is a 85% chance that a randomly selected individual will have a GRE score less than 1245. So there's different ways of interpreting it as probability or proportion. So if we move on to the next example, where it's a different situation, right? It is known that the length of a certain steel rod is normally distributed with a mean of 100 centimeters and a standard deviation of 0.45 centimeters. Suppose the manufacturer wants to accept 90% of all rods manufactured. Determine the length of the rods that make up the middle 90% of all steel rods manufactured and use 2 decimal places. So here, let's go ahead and highlight. Let's do our red flags, right? So I do know that it's normally distributed, which is very important. A mean of 100 centimeters, standard deviation of 0.45, and the manufacturer wants to accept 90%. So there's our barrier. So I'm going to go ahead and put 100 in the middle, put my line as I usually do, and I'll go ahead and add and subtract 0.45 3 times to the left and right. So it does get a little bit small, so I'll do 100, 0.45, 100.9, and then 101.35. And to the left side, I have 99.55, 99.1, and then 98.65. So I want to accept 90% of all rods manufactured, and so determine the length that corresponds to the middle 95%. Ooh, that's interesting. The middle 90%. So where is that? Well, I do know from the empirical rule that this is 68%, one standard deviation, 95% is 2 standard deviations. So let me draw the barrier. So that means 90 is somewhere between 1 and 2 standard deviations away. So I'm looking for this C1 and a C2, right? I'm looking for 2 C's. And this is the middle 90%. And you're like, what? There's going to be 2 C's? Yes. And is it going to be a lot of work? No. Because why? We're going to use the calculator. And your calculator knows how to do the middle and will give you the 2 values. I know. I love it. Okay, so this means that I'm looking for now the probability or area such that x lies between C1 and C2, in which will be the middle 90%. Okay, so now I know some information. I know the mean is given to be 100 and standard deviation to be 0.45. Okay, so let's go ahead and put it in the calculator. So now the set, it's going to give it to us as a set. So the set of C1, C2 is going to be equal to invnorm, area in the middle, right, 0.90, mean 100, standard deviation 0.45, and then we're going to select center. So go to your calculator, go to second bars, go to invnorm, which is number 3, and we'll go ahead and put the area of 0.90, the mean of 100, standard deviation of 0.45, and go ahead and select center. You're going to love this. You're going to love it. And notice it says center. Hit enter. You're going to see 2 numbers come up. Boom, boom. So C1 is 99.25, 26, right? So 99.26, comma, 100.74. And so I'm just rounding to 2 decimal places as they asked in the directions. So here, if I wanted, okay, so these are the answers, right? You would just put these numbers in the entry box of mom. And then you would say, okay, so the lengths that are accepted of all rods manufactured are 99.26 centimeters and are between the lengths that are accepted of rods manufactured are between 99.26 centimeters and 100.74 centimeters. So in this case, I guess you need to ask the question when you have these in My Open Math, right? Are you looking for area or are you looking for the value given an area? If you're looking for a value given an area, you're going to use invnorm. So let me go to right here on the next page, I'll write it. So let's do this. Note. Right, so the first case that we did in this section is ask for area or probability. Then you're going to use normal CDF. The second situation is, does it give area and ask for a value? If it gives you the area, know that you're going to use invnorm. Okay? And the nice thing about the calculator that we have is it doesn't matter which area they give it to you, the left, the middle, the center, because in this case, it will ask for where it's located and you just enter it and then it pops up the value that you need. So in a nutshell, if we go down to the very last page, essentially what it's just saying is because we're using z-scores for area, an area given a distribution with normal CDF and invnorm, like how do we represent it? So, because all these z-scores, for example, let's say here's 1, 2, 3, 4, -1, -2, -3, and then here's the middle. So how we represent that is doing like a z-score sub alpha like this. And the alpha represents that area to the right. And we're going to learn a lot more about this in future chapters. Just so you know, you're going to this notation, it doesn't go away. Like we want to introduce it now, that way it's familiar to you when we actually start just digging our heels in and using it. So let's just say, for example, I have a z-score over here, right? And then, so this is say 0.08, right, is the area. Then we would name this z-score that go along with this z.08. So we would have the z and the sub alpha would be the area 0.08. So notice that the area to the right is this subscript. And the z-score represents the standardized from the distribution. And we use this a lot. It's very helpful, but we just want to kind of touch base and introduce to you now what the alpha represents.